So let's begin. First of all, let us look at this question. We need to find the value of alpha plus beta, and the value of this limit is given to us. So let us proceed. First of all, let me write the question. Okay. Now let us observe what is happening in the numerator and the denominator. So the numerator is tending to 0 and the denominator is also tending to 0. So this is a 0 by 0 form. So what we are going to do is using L'Hopital's rule, and to differentiate this integral we'll use the Leibniz formula. So this reduces to limit extending 0 alpha by 2 1 by 1 minus x square plus beta cos x minus x sin x by 3x square. Okay. Now let us look at the expression. So the value of this limit is equal to 2, right? So the numerator tends to 0, which means that in order to get an indeterminate form, the denominator should also tend to 0, so that we can further simplify this expression. So let us put 0 in the numerator and equate it to 0. So alpha by 2, when we substitute 0 in the numerator, we get alpha by 2 plus beta is equal to 0, which implies alpha is equal to minus 2 beta. Now we got a relation between alpha and beta. Let's substitute this relation in our original expression and figure out the rest of the terms. So now our expression is this. Beta cos x minus x sin x. Think what I wrote over here. You'll find out that it is correct. Okay. I won't go into the detailed part of the calculation, as you can figure it out by yourself. 4 divided by 3x square is equal to 2. Okay. So what I am going to do now is add subtract 1 to the numerator, to this part of the numerator, alright, this bracket part, because the idea which I'm getting now is x sin x can easily be simplified along with the denominator, but cos x we need something to simplify this. So you might have heard of this formula, limit extending 0, 1 minus cos x by x square is equal to half. So this formula clicked to my mind, and hence it is going to help me in the manipulations. Okay. So let us add subtract 1 to the bracketed part. It is equivalent to adding subtract alpha, adding subtract beta to the numerator. So this will become limit extending 0. Let us take beta by 3 common. We'll get minus x sin x divided by x square minus 1 minus cos x by x square. Think of it, whatever is written over here is correct. Now that I subtracted 1, I'm adding 1 over here, and this will become x square by 3 x square by x square minus 1 times x square when I added 1 over here. When I'm subtracting 1 over here, I have to add 1 also, right? So that 1 I'm adding to this term. I'm clubbing that 1 with this term, and the thing which I will get is this. Okay, let me add another page. Okay, so now time to simplify the expression. Beta by 3. Let us take the minus sign outside. We'll get this term will tend to 1, right? Plus, because we have taken out the minus sign, this term will tend to half, as I told you before, and this term again will tend to 1, right? After I take out the minus sign. Observe carefully. And this whole thing is equal to 2, which implies minus 5 beta by 6 is equal to 2, and beta is equal to minus 12 by 5. Great. Now that this is done, let us comment on to the final answer. I have to calculate the value of alpha plus beta, but I know that from over here, I know that alpha is equal to minus 2 beta. From here, I know that alpha is equal to minus 2 beta. So when I find the value of this expression, it will be minus 2 beta plus beta, which is equal to minus beta. So what will be the value of, what will be the answer here? The answer over here will be minus beta. What is the value of minus beta? We calculate the value of beta here. So the value of minus beta is going to be minus 12 by 5. I mean 12 by 5, which is equal to 2.4.